This should be the easier page. Write a degree 4 polynomial that has plus 2 as a 0, minus 2 as a 0, and minus 1 plus 5i. Well, let's get started here. If plus 2 is a 0, x minus 2 is a factor. If minus 2 is a 0, x plus 2 is a factor. If minus 1 plus 5i is a 0, x minus this is a factor. And if I get a complex factor, the other 0 has to be the conjugate, where the quadratic formula gives you minus b over 2a plus or minus the square root of b squared minus 4c over 2a. This gives the I, and that part, the I part, is plus or minus. So the other one has to be still minus 1, but minus 5i. So if that's a 0, the other factor is x minus this. And then you could multiply by anything out here if you wanted. But y equals, I'm just going to leave it like this. Other than I could distribute the minus on here and call this x plus 1 plus 5i. And I could call this x plus 1 minus 5i. Okay. Solve for when this is greater than 0. Oop, I got a 7 here, so this is number 7. Okay, so this is a bounce. So I'm going to kind of write the number line, and I know it's going to bounce at negative 4. What makes this 0, let's see, it's 2 minus x. 2 would make this 0, so at 2 there's a 0, and at minus 1. So it bounces here. It goes, this happens only once, so it goes straight through here some way, and it goes straight through here. So if it bounces, it's got to go through and through. So it could go like this if it's a positive x to the 4th. If it's a negative x to the 4th, it would do bounce through, and go this way. So which way is it? Well, we got x squared times the negative x times an x. X times the negative x is negative x squared and an x squared. So I get negative x to the 4th. So it's an upside down one. And I could check that. See, between minus 1 and 2 is 0. If I put 0 into this, I get 4 squared, which is 16. Put 0 in there, I get 2. Put 0 in there, I get 1. Is that greater than 0? Yes, it is. So at 0, it's greater than 0. So it is up here, going down, bouncing and going down. So when is this graph greater than or equal to 0? Well, it is equal to 0 at negative 4. So if I'm doing interval notation, I would say from negative 4 to negative 4, it's equal to 0, so I've got to include it. Union, because there's no space there, it's just right at negative 4, and then it's from minus 1 to 2, it's greater than 0, and at minus 1 it's 0, and at 2 it's 0, and it's okay to be 0. So there's the answer to that one. And finally, this one. And this is a lot of estimation. So the factors, let's see. It looks like it goes through minus 1, minus 2, minus 3.1 or 3.2, minus 3.2. So the factor would be x plus 3.2. Go straight through. goes straight through here. That's minus 1.1 or 1.2. If it's minus 1.2, it's x plus 1.2 or 1.1. And this one looks like it's about 0.3. So the factor would be x minus 0.3. And it goes straight through, so it happens only once. And then it goes straight through here. Let's see, it's 2, 3, 4 here, so 3.8. 3.8, so the factor is x minus 3.8. Now that would go x times x times x times x. That's 1, 2, 3, 4, 5. 1, 2, 3, 4. I'm missing one. What did I forget? 3.2 negative 1.2, 0.3. Oh, I missed this one. 1.8. So I got one more factor here at 1.8, which would be x minus 1.8. So now I have a degree 5. Crosses 1, 2, 3, 4, 5 times. 1, 2, 3, 4, 5. So that's normally that starts down, goes and ends up. But this goes upside down, so we have to put a minus. But we might have to put something else in. So I'm going to go to my calculator, and I'm going to y equals and clear, and I'm going to type in, I know it should be negative, and I know it's parenthesis x minus 1.8, x plus 3.2, close parenthesis, open parentheses, x plus 1.2, close parenthesis, open parenthesis, x minus, not minus, subtract 0.3, close parenthesis, open parenthesis, and x minus 3.8. You could put this in on Desmos also. And if I push zoom 6 to get a standard looking graph, or even zoom 4, which might be a little closer, it went through back here at minus 123.123.2ish, yes, minus 1.2, that looks good, but it's not going through 1.5 on the y. It's way too high. So how do I squeeze it vertically to get it less high? Well, I would multiply it by maybe by 0.5. Let's see what that would do. So I'm going to put in here second insert 0.5. So I'm squeezing it by half as high. It's still too high. It's at 1, 2, 3, almost 4. So I need to go half of that. So half of 0.5, maybe 0.2. So I'm going to change that to 0.2 and see. Oh, that's getting closer to at 1.5. That's about right. So I'm going to go with 0.2. So it's y equals negative 0.2 times all these factors. And that's that one.